Good morning, ladies and gentlemen. First, I'd like to thank the organizing committee for inviting me, and thank you, Jared, for the very kind introduction. We had a very, very good start yesterday and this morning. And I must say, it's difficult to go next to Keith, because he did a so fantastic job, and he probably expressed things much better than I could do. And I guess you'll see there are probably a good convergence. Now, in preparing this talk, I found myself a bit completely torn apart, because as chairperson of the theme 1, which is heavily technology-based, I thought I had really to talk about technology, but in the same time, I pretty much share the same ideas and concerns that Keith expressed and a lot of others have expressed over the years. So I had to find a way to reconcile the two. So I'm not sure about the result, but you'll let me know. So it's probably fair to say that technology drives our lives. So, 10 years ago, we needed a lot of different instruments or apparatuses to take photos, listen to music, check email, etc. Nowadays, it's all much easier. So I have a teenage girl and an 11-year-old girl. I can tell you, it's another world. We feel really like old farts. Now, what does it mean? What does it mean for us in forensic science? We can see a bit what happened technology-wise, and I'm not a DNA person, so please don't challenge me on that. But it's pretty much a quick timeline and what happened in DNA over the years, how the technology evolved. And basically here, it's all about discrimination, sensitivity. Then we've got the finger mark detection examples. So over the years, we went from the good old powder to very advanced techniques. I'm sorry for the free marketing exercise here, but in our group, we have been very active to develop cutting-edge methods for finger marks. So Dr. Xanthi Spindler will talk about some immunogenic methods. And Michael Wood is doing his PhD on an extension of that, looking at aptamers, which are kind of synthetic antibodies trying to target finger mark secretions. So you can see it's pretty interesting science. Now, there are other recent advances in computing, IT, communication, technology, all the digital imaging and signal treatment. Keith showed a few nice practical applications of all that. Machine learning to assist discrimination, automation, computer modeling for incident reconstruction, remote communication, get the information quickly at the scene. Everything is transferred wirelessly. The digital era is completely revolutionizing the concept of identity. And there will be a very good talk given by Professor David Olivier Jacquet-Schiffel about that particular theme. And the analytical sciences, obviously, are at the crux as well of all that. And we've seen huge progress. Things about imaging and mapping facilities for chemical analysis, the well-advanced mass spectrometric techniques, surface desorption techniques. In the DNA area, we moved to the next generation of sequencing. There's a lot of interest in DNA phenotyping and these sort of projects. The National Institute of Forensic Science in Australia organized last year a forum from research leaders in enabling sciences as part of their renewal of the innovation strategy. And these were the conclusions. So the people outside forensic, but dealing with enabling science, I won't say real science, as opposed to what we are doing in forensic science, they came to these conclusions. So there is no real DNA around the corner, but there are different areas which will bring some challenges and obviously some opportunities. So a few examples. These are all the nice tools that have been developed, recently, and there has been a lot of work on isotope ratio, different desorption techniques. This is a hyphenated method we have at UTS with the C and QTOF mass spectrometry, hyperspectral imaging of all different types, obviously the DNA sequencing by synthesis, robotics, if everything can be automated, fantastic. And obviously for frontline policing, you have things like live scan technology. In terms of IRMS, I guess there has been a growth of interest and publication in the area. To some extent, it has complexified a bit because it's a bit difficult to interpret all this data. So again, pretty much very selfish marketing here. Kylie Jones from the AFP will present a talk about her project on the analysis of paper, and you can already see, there are interesting things going on where you can discriminate between different countries, different batches, and so on. There has been this other theme as well, miniaturization. So we've seen in the analytical sciences something that happened in the, in the transistors and electronics before. So things which were very bulky became smaller and smaller and smaller and smaller. And I was talking to someone yesterday and talking about the computing power when people went to the moon, that it's smaller than anyone would have on his phone or her phone today. So it's pretty amazing. So there are some of the tools that you can, probably have been proposed to your lab, or you've tested them, all these different types of analytical instruments, from FTIR to GCMS, ion mobility, etc., systems which can be portable and sometimes handheld, like even XRF, XRD, you name it. There is always some kind of a portable version. Now at UTS, again, we've been doing some work in the field of capillary electrophoresis and lab on a chip. So we've got a postdoctoral fellow from originally from Brazil, Lucas Blanes, and he built this system himself, and it's like a shoebox. So if it's professionally engineered, I'm pretty sure that it can be much, much smaller. And there is potential for a lot of things in terms from clean lab analysis to explosives and so on. We've done a lot of work in the lab on chip systems, especially the bioanalyzer from Agilent. So we've changed the chemistry and did a lot of things there to be able to use that system to analyze explosives and now drugs at the scene. Now, this is some cutting-edge research that he's doing to go into the sort of dirty and cheap analysis at the scene, and trying to make some paper-based microchips where you could have very simple tests at the scene, say, to detect explosives, on a screening basis. Now, with all this, especially the portable instrumentation, the problem is, if you talk to the vendor, and sorry, I don't want to offend anyone from the exhibition, but they always have the miracle solution. And it's very hard to get real research and test all these instruments. And things are done in a lab, not necessarily communicated to another lab. Pretty much what Keith said this morning about sharing the information. The NFSTC in Florida, they have this website. You've got the URL here. And you can download reports that people have produced and are happy to share about these new instrumentation. So if you're interested, it's probably good to have a look at that. Now, probably to follow on from what Keith said this morning. Now we can ask the question, are we too much interested in discrimination? Each time I go to an NIJ Trace Evidence Symposium, we've got all these discussions, all these talks about, okay, trace evidence is not DNA. We can't get to, good discrimination and so on and so on. But Keith expressed that very well this morning. It's not only about who or what, but there are other questions. And I was glad that he put Locard's exchange principle. There is this notion of activity, and it's quite often forgotten in what a lot of people do. Will these questions ever be solved by technology alone? I don't think so. I think a human is needed here to ask the right questions and go through the process. Nevertheless, there are interesting pieces of research going on in these sort of areas, like Céline Weyermann, Professor Céline Weyermann from Lausanne. She's got a few presentations, and including an oral, about dating issues in forensic science, and not coming from a pure technical viewpoint, but really across the board of the field. And there is very nice research going on here. There are other research potential in that sort of area. Again, I'm not a bio person, but I understand that there are some some potential here to try to get to the other types of questions. Now, I think there are some serious risks with new technologies. And here you've got a list. It's probably not, exhaustive, but it's slow, it's expensive, it's done in the lab, it increases the complexity of the results. Quite often we are about sensitivity, not necessarily relevance. It gives a sense of comfort, if I do an extra test, I'll be more confident. But how do you know? Does it really change something? I can see in the fibers area, for example, each time you come with a new technique, the first thing is a lot of skepticism because it's already so good in terms of discrimination. The pool of techniques that can be applied, they are already so good. So what to go the next step? There are other things to investigate and look for. The problem of holistic approach, confusion between technology and science. Good technology doesn't make good science. And uncertain value for investigation and the criminal justice system. It goes along pretty much about what Jared said in the introduction. And I don't want to claim ownership of this field because there is a fantastic group of researchers at the University of Tasmania on the sociology side leading that research. We are part of it, as others like Lausanne and different other people, but it's very important. I don't want to spend too much time on this one, but with all the discussions in recent years, especially after the ANS report, I had this old case that I did in Switzerland more than 16 years ago. It was a gunshot residue case. We couldn't apply SEM because the whole thing started as a biology/DNA casework. And then when we realized that the relevant questions were about the use or non-use of a firearm, we had to deal with a specimen we had. We couldn't do SEM, so we went for a bulk analysis using ICP-MS at the time. We had abnormal levels of lead, barium, and antimony on the right hand. So we used well-established analytical methods. ICP-MS already at that time was already there. You use standards in the lab. We know the uncertainties of the technique and so on. We looked at previous research. We had levels of blank in the population. Everything was there. And everything was pretty much indicating to us that there was a good chance. I don't want to put that in like little racial terms because we didn't have all the data, but there was a good chance that the defendant used a firearm. Now, little critical thinking. Was there any gun found in this case? No. And then we had a lot of good interaction with the police, and it will horrify a lot of people interested in contextual bias and control of forensic labs. The person who collected the specimens at the scene was actually doing his own PhD in the same lab as me. So we could share completely freely the information. And then we realized that actually the defendant had broken down with his car, hidden the car, took off the number plates for whatever reason, and when he arrived at his place where the police was waiting for him, he had the plates under the arm. So we thought, maybe we should check the number plates. And guess what? There was very high level of lead, barium, and antimony. So we were nearly there, even if the hard science or analytical science was right. Now, another thing that happened in recent years, it's really this sort of crystallization that forensic science is not a real continuum, but there are different chapters, different chunk of work done at different times of the investigation and court case. Now, we would think that we should use analytical tools differently, or different tools at different levels. Now, the reality is we are mostly driven by the court process. So we always want to be foolproof right from the start. And that generates a lot of issues, especially in the beginning. So that's the reality. We overheat in the lab, sometimes to state the obvious, and we don't necessarily have a good feeling about the value for police and justice. Now, because of our research and interest with the research we're doing with the University of Tasmania and collaborations with Olivier Ribot in Switzerland, we came to be interested in what people say about forensic science in the broad criminology area and sociology area. And that's just, again, it's not exhaustive. I'm not claiming it's even completely representative, but you can see some indications here. There are big question marks, big skepticism. So we think that we do all great because we have all the latest tools and the latest high-tech toys. But do we really fulfill, our obligations? It's open to discussion. So sorry, Pierre, I had to put that. And I think part of the issue is to pretty much what Keith said this morning. We have to go back at the roots. We have to go back at what it means, what forensic science is. And Professor Margot came to Australia as a plenary speaker in 2010 and talked about what is the law of the land in forensic science. And it's an excellent paper, and he had this full definition, which really goes back to traces as remnant of the crime. And if we look at this way, and not from the technology angle, we can really capitalize our tools, because we've got nice tools. So really, we have to focus on traces, because they have all these nice features. It provides leads, eliminates suspects, reconstruct the events and their sequence, establish charges, identify links in serial crime. And, analytical tools can be helpful, but they are not really driving everything. And again, because of the recent research we've been doing, really, we could see that there is this expanding role of forensic science, which goes beyond court consideration. So we shouldn't be only driven by court consideration. And when we look at traces as remnant of the crime, then we go at, pretty much by proxy, almost studying crime. So we're very close to criminology in the end. And I'm sure Keith will know that, with all the early times of the school of California, criminology was a big component. Now, I think we are at the crossroad here. To put it a bit differently from what Keith said, but the message is pretty much the same. So what do we want with forensic science? We want a Photoshop, and not a Photoshop, an app for your iPhone, but a real Photoshop, where basically we are at the counter, and we take whatever is given to us, and people say, okay, I want 2 copies, 3 copies, that size, without any control of anything, without really necessarily. So we perform the quality very well in that environment. We know that the machines are working, the bath, the chemicals are okay and everything. But we're not really sure if it's what the other person wants. We're not really sure if it brings a lot of value in the end. Or do we want something like a hospital, where you've got this sort of body of knowledge and professions, and you can tap into specialties and high-tech tools whenever it's needed. But it's not. There is a real critical thinking and problem solving. Someone is sick, goes through ER, it's a problem to solve, and we're going to try to solve that in the best ability of what we have. Now, it's funny because I didn't talk to Keith before this morning, but again, there is a bit of convergence. Talking about forensic science 2.0. Sorry. I think it's really crucial to develop our own models and framework that are fit for the use of science in policing and justice, not simply use accreditation models that are used for labs that are remote from crime scene. These models should be used to integrate and assess the information we have and observations that are available to understand the problem, detect pertinent traces, identify the relevant hypothesis, identify the best course of action, and provide potential answers. Technology provides the tools to solve these questions. So again, don't get me wrong, it's not poo-poo against technology, it's very crucial, but we have to use them appropriately. We need probably more breadth, not depth. we need to integrate different sources of information together rather than going in one and going through. So if you are from an analytical science area, you will understand if we talk about multiplex advantage or this sort of concept. So what about forensic science 2.1? I didn't put 0.5. I was probably harsher. I put 0.0. But I think we have to think seriously about that. And in terms of integration, this is just a little example that I had from, thank you, Quentin, from Lausanne, because I saw in the abstract something very interesting. You know, this integration of information coming from the web and from chemical analysis on illicit drugs. And when you combine the two, you get information about the illicit drug market structure. So if you are a chemist, pure chemist, doing drug analysis every day, I think you have to have a very huge level of lateral thinking to think about going through the web to get this sort of information. And the same probably from the IT angle. So to answer the question, technology enabler or disenabler, I think forensic science is about asking the right questions. The problem-solving process should drive us, not the technology. Traces as remnant of crime should drive us, not the methods and techniques. And again, we all agree, this conception brings crime scene examination to the forefront of the whole picture. It's where everything starts. So we have to be there as scientists. Now, having said that, I don't want to annoy everyone who is presenting a very nice piece of work using a very high-tech techniques. It's not the point. And I think that's important as well. You know, it doesn't mean that the forensic scientists shouldn't really keep up with the development. And you know, if you can afford it, go to PitCon. You know, here and then, check what's on offer. But think about how that could be used in the forensic work, not in an analytical laboratory. You know, it's amazing to see that 40 years probably were between the discovery of the hydrogen reaction with amino acids and until it was proposed by Oden and von Hofsten as a reagent for finger mark. So it's not good enough, really. And Neil Armstrong said that we are very bad at prophecy in science. And when you look at that, 1949, the big prophecy was computers would be less than 1.5 tons in the future. So look at your iPhone and just think about that. So a few acknowledgements. Thank you to all these people who have contributed one way or the other to this talk. It's always collaborative, and it's how it works. And I hope the little video yesterday didn't put you off. It's a long way to go to Australia, but it's always, we like to have you there. So there is a conference in Hobart in a few weeks' time. I thought it was probably too late to advertise that. But if you missed that one, there is, in 2 years' time, another one in Adelaide. So I hope to see you there. Thank you.